Today we are going to visualize sound waves. In this Max MSP patch, this simple audio sample is taken and is processed by a bunch of Max MSP and Jitter objects in order to create a visualization of the sound wave. This is a very intuitive process and it only uses a few Max objects, but the result is really cool. And you can take the result and apply more visual effects or audio effects to craft very intricate audiovisual narratives. Let's see how it's done. If I directly want to turn sound waves into visual music, I need to do three things. Number one, I need to somehow import sounds and play it, right? Or some kind of audio. I then, step two, need to turn the sound into visuals. And this is the cool part, right? This is what we call visualization. And three, I need to do cool things with the visuals. And this is what we call VFX, visual effects. So it seems pretty simple, and I think in this case we can just follow these three steps one after the other. So how are we going to import sound? Well, it's fine as long as we have any kind of audio signal in our Max patch, right? But I'm going to go here and I'm going to pick some kind of audio sample to use in my patch, right? I'm going to use the vibra.mp3. This is a part of the upshot package in Max, but you can use any kind of audio file you want for your visualization purposes, or live microphone input, or some kind of synthesizer or digital instrument output. It's fine as long as you have this signal patch cord right here. So I also want to play this, right? So I'm going to create the live.gain tilde object, and this is going to be my volume control. And then the result of this is going to go into EasyDAC tilde, right? This is going to kind of send the sound from the patch to my audio output device. So the outlet of vibra.mp3, or more specifically, the playlist tilde object, goes to the first two inlets of live.gain, and the first two outlets of the object goes into EasyDAC tilde. And if I lock the patch, click on EasyDAC, turning the audio on, and then press the play button, I'm going to hear this beautiful vibraphone music. Beautiful indeed. So that is the first step, and we have now an audio file in our Max patch. There are perhaps infinite amount of ways to take a sound and turn it into visuals, or at least ways close to infinite. But today we are going to focus on two things, right? Actually a pair of objects called jit.catch tilde. As you will see, it has a very funky name, this one. And jit.graph, an object made to be used in tandem with jit.catch. So what is jit.catch tilde and why does it have a funny name? Well, the jit dot at the beginning, right? It means that this is made as a part of the jitter side of Max MSP, right? So it deals with visuals, it deals with matrices and so on. But then it has a tilde at the end, which is the convention for MSP objects in Max, right? So it also deals with audio. It deals with audio signals or any kind of signals inside Max. The point of jit.catch is to take in any kind of signal, any kind of audio signal, and turn it into a jitter matrix. It is a very complicated object, right? I'm going to show you the surface level for now, but with this object you can do a lot of cool things as you convert audio signals into jitter matrices. And I think the most straightforward example is in the help patch, right? So when I right-click the object and choose open jit.catch tilde help, I can see a very straightforward example. Right, so here is an audio signal going into jit.catch, but there is something else going in here as well, this QMetro object with the argument 2. I will explain this in a second. For now, just know that I have to turn this on. And then you might notice, jit.graph is here as well. The output of jit.catch is routed into jit.graph, but also the output of jit.catch is being visualized here. So we actually get two visualizations for the price of one, which is a very good deal if you ask me. Now, if I lock the patch and click on this play button here, look at what happens. We hear our lovely Anton.aif, and we see this graph visualization, kind of approximating the waveform, as well as this little, very subtle effect here, the direct output of jit.catch. Look at this. This output is a direct output of jit.catch, and it shows the waveform through these stripes that are either very bright, meaning the waveform is going up, or very dark, meaning the waveform is going down. This is the first thing I want to look at. I want to look at and understand jit.catch before we go into jit.graph. And now we know that we need some kind of audio input into jit.catch as well as QMetro, whatever that does. So QMetro is the sibling, is a gentler sibling object of Metro. You might know Metro as one of the most basic max MSP objects, right? You give it an argument, an interval in milliseconds, you create a toggle, plug it in a Metro, and what comes out is, when you turn it on, just a constant supply of bang messages or bangs at the interval in milliseconds that you give as an argument. QMetro is going to do the exact same thing. You give it an argument, in interval in milliseconds, you create a toggle connected to QMetro, and the output is going to be a bang message as well. The difference is this. If and when your patch is overloaded, if there are too many things happening that your CPU is struggling a bit, Metro is going to try to force things and slow your patch down even more. It's going to make sure that all the bank messages one after the other pass through. This is good for, let's say, timing purposes and order of operations purposes. But in certain other cases, it is okay for us that the bank just drops, just does not happen, or waits for the other operations in the patch to be completed before being sent out. And that is what QMetro does. QMetro is a metro that respects the event queue, or that is gentle towards the event queue. Long story short, if timing to the milliseconds of detail is not that important in your patch or in this specific instance, it's always better or a better idea to use QMetro. So plugging this in here, right, and logging the patch, I'm going to turn on QMetro. Now it's being sent in here. I will unlock the patch and I will create an object to visualize the output of jit.catch called jit.pwindow, short for patcher window. Jit.pwindow is the name of our object, and it's going to visualize the jitter matrix, the information coming out of jit.catch. So let's see what this looks like. I'm going to again lock the patch and click our play button. All right, so we got some beautiful patterns, but notice that this is very choppy. And this is choppy because our interval for QMetro is 100. And you want something lower than 100. Ideally, you want something lower than 50 in order to have a more fluid effect, in order to have a more fluid flow of data. Of course, lowering this interval of QMetro is a parameter you can play with once the entire patch is complete. And the smaller this interval is, the more fluid the visualization is going to be, but we are going to see smaller and smaller slices of the audio waveform from the output. If this object interests you a lot, you can always right-click and look at the help patch further or check out the reference for other options. But for our purposes today, right? We have a nice visualization that we can plug into jit.graph. And jit.graph doesn't need anything apart from the output of jit.catch or something of the equivalent sort. I can again create another jit.pwindow to visualize this result. And you can see it immediately has a different color, right? It's this, in my opinion, a very ugly brown color, and there's this weird yellow color on top. I don't know why these colors were chosen. But now, if I again log my patch and play my audio sample, I'm going to see a graph visualization of the waveform. All right, it does look pretty cool, apart from the color and a few other things. And I would say we are done with the second step. The sound is now visuals. The sound has turned into visuals. We have accomplished visualization, even though it's not the best visualization ever that we have done in the world. But we can use this as a basis. We can refine this, we can change the colors, change the resolution, and apply some visual effects. So we can do cool things with the visuals. So how are we going to do this? So I'm going to focus on the output of jit.graph, and there are 3 things I want to address. 1, draw mode, how these waveforms are drawn. Right now, I don't know if you're noticing this, but they are drawn as a bunch of points that are not really linearly connected. So it looks a bit choppy. So I would love to play around with the options for that. I would love to have less ugly colors, right? Again, it's my preference for colors in my audio visualizations, but brown and yellow do not really evoke cool aesthetic feelings from me. And 3, I would love to have a higher resolution, because as we are going to see, once we put this on another window apart from our max patch, it is going to look very low resolution. So for most of these things, we are going to play around with the attributes of the jit.graph object. And the easiest way to play with attributes is to unlock the patch, go to the first inlet, and right-click it. Then at the top, you can see all the attributes of the object. And for the draw mode, we have to find, there we go, the attribute that says mode. Clicking it is going to bring up this nice object that is already connected to jit.graph. So now I can lock my patch again, click on the 0 points, and then choose another draw mode, like lines, and now we can see it's being visualized as lines, or area, which visualizes the space between the middle point and the waveform as an area. It fills that in. Bipolar area, which is going to create the symmetry between the top and the bottom half of our visualization, or bar, which works a bit weird, so I'm not going to even try to show it in this video. And for what I want to do, I like the area kind of visualization, but as always, you can do whatever you want with this mode and explore the different kinds of visualizations. Now, how do we do less ugly colors? Well, I can, again, right-click the first inlet of jit.graph when my patch is unlocked and choose 2 important attributes, which are called brgb and frgb. And if you are already not so bad at this, maybe you have an intuition for what these 2 things mean, or maybe you are thinking, what is exactly brgb and frgb? Who has come up with these strange names for attributes? But it's simpler than you think. This is background color, brgb, background color in red, green, and blue. And this is foreground color, right? So the color of the line, foreground color, not in RGB, it's a misleading name. This is actually an ARGB, right? So alpha, red, green, and blue, and this one is in RGB. In any case, the values here go from 0 to 255, right? So 3 numbers, each being the amount of red, amount of green, amount of blue, where 0 means no red or no green or no blue, and 255 means maximum red, maximum green, maximum blue. And we are going to get our colors by mixing these 3 values. Now, for the background, I want the background to be completely dark, completely black, and I want my foreground's waveform color to be my favorite greenish color. So I'm going to lock the patch yet again, and I'm going to change the background color to 0, 0, and 0. And you can immediately see the background is now completely black. For the foreground, I'm going to make the alpha value 255 because I don't want it to be transparent. But then I'm going to make the red 0, no red. I'm going to set the green to 255, maximum green, and I'm going to set the amount of blue to 150. So a nice tinge of blue there, and then we get what is my favorite color. You can, of course, as always, play around with these to create your own cool colors. And finally, I want to play around with the higher resolution, right? And for the for the width of my resolution, right, I am going to change an attribute of jit.catch. I'm going to right-click on the unlocked patch and choose frame size, right? And this, for our intents and purposes, is the width of our visualization. Right now it's 320 points or pixels or samples or what have you. But I can, again, lock the patch and choose a very high value, like, I don't know, 1920. Now, when I go to jit.graph, I can try to change the height, not the width, but the height of my visualization by right-clicking the first inlet of jit.graph and choosing height. So it's that simple. Here it's just called height. I can, right now it's 240, I can lock this and choose a very high value like 1080. And now in the recording, maybe you can already see that this visualization is looking a bit sharper, but this higher resolution is really going to pop out once we bring it into our do cool things with the visuals part of our patch. And that is going to use, or for this, we are going to use the object called jit.world, which you might know. It is the Jitter.world context, right? So if we want to do advanced things with visuals and we want to show this on a separate screen, maybe project it somewhere apart from our max patch, we have to use jit.world. But we also have to give jit.world some arguments and attributes, right? As an argument, we have to give it a name. So I'm going to give it the name cool visuals, because I'm very creatively bankrupt right now for cool names. So the name doesn't really matter, but I'm also going to give it two important attributes. So at floating, I'm going to set this to 1. This will make sure that my window always is in front of my patch so I can still edit things and immediately see the visual result. And secondly, I'm going to add an attribute called preserve_aspect, and I will set this to 0. I will tell jit.world not to preserve the aspect. You will understand what this means in just a second. So my cool visuals window is here. My jit.world object is here. Like Metro, like QMetro, I do need to create a toggle connected to jit.world. Oh, there we go. Lock the patch and turn this on. And now our jit.world context is running. Now, if I want to show any of this in my jit.world context, I can do something simple. I can take the matrix output of, let's say, jit.graph and plug it into the inlet of jit.world. And look, we immediately have the visuals appearing right here on our beautiful window. We can even hear it, perhaps. There it is. Beautiful. I especially love how we can tell if the sound is pure, if it has a lot of harmonics or not, or if it's a bit noisy, just based on the shape of the sound waves. That's something really cool and intuitive. So preserve aspect, the attribute preserve aspect, makes sure that if I squish the window, change its ratio, whatever visual I am sending to jit.world is going to be scaled to fit the window, right? That is what preserve aspect does. Now, when we have done this, right, when we are directly sending the visuals to jit.world, we can actually do something very cool, and we can kind of intercept this matrix, intercept these visuals with some visual effects. And now what I'm going to show uses the new Max 9 objects. In fact, it uses the latest version of Max 9 at the time of recording of this video. And it is a bunch of objects that start with jit.fx.something, jit.fx.something. Right, all of these objects, jit.fx.vhs, jit.fx.hue, not HYE, but hue, or jit.fx. I don't know, slide. Right, all of these objects use the graphics card of your computer to process visuals. This is important, right? If you are doing something pretty cool musically or sound-wise in your patch, that will happen on the CPU. And you want to use visual objects, or objects that modify the visuals that run on the GPU, and this is what all jit.fx objects do. And as you can see, there are a lot of them, so you can always try to explore them, look at their help files, and see what they do to your visuals. So for my thing, I am going to first try jit.fx.slide, right? And if I right-click and go to the help patch, it is described as a pixel-wise temporal envelope follower, which is a very fancy way of saying it's going to blur the image a bit. Right, it's going to blur the image as the values go from darkness to light or light to darkness. It might leave some trails, which is really cool for this kind of visualization. Right, so I can plug my jit.graph output in jit.fx slide and then take its output and put it into jit.world. I just need to give jit.fx slide a single argument called, let me think, slide underscore down, and then a value like 50. And look at the change. Suddenly, our waveforms are leaving these cool trails, right? Because slide down means as you go from a colorful pixel to a dark pixel, make it take 15 frames. Do not immediately go to black. If I increase the slide down value, you can see that it leaves even more trails. This is a very cool, a very intuitive effect for adding some, what I would call visual reverb. And now something cool we can do with these effects, if I am using this kind of slide effect, I can add another kind of effect that modulates, that changes the visual before it goes to slide. And I can automate this visual effect, so each time we have this change, this slide, it reflects the change in the original visual effect. If what I'm saying does not make a lot of sense, let's just explore it in practice. So, instead of jit.fx slide, which is still here, I'm going to take jit.graph, plug it into jit.fx hue, and plug that into jit.world. And look, there's nothing happening. There's nothing changing yet. But now I can right-click the first inlet, choose the attribute called hue of jit.fx.hue, lock the patch, and set this 0 to different values. And if you have working eyes, you might notice that, oh, this changes the color. This shifts the hue of my visuals, right? And this happens in a range from 0 to 360, a complete circle, a complete rotation in hues, right? So 360 is going to equal whatever hue I have originally at the 0 point. Now, fun fact, I can also send a number, right? I can create, let's say, f, a floating number box connected to this attribute object's inlet, and then directly manipulate it through here. And a cool visualization trick, right? If we are visualizing sounds, I can always take like a simple aspect of the sound, like the, I don't know, the amplitude, and then tie it to the modulation of a visual effect, right? So the shift in the hue will correspond with the amplitude of my sound, of the sound that I'm visualizing. So let's do this pretty quickly. I am going to use an object for detecting the amplitude of the signal called peak amp tilde. This object requires an argument, the interval in which it reports the peak amplitude. 33, as you can see, is a very good number for this. I can then plug my audio signal into peak amp, and the output is going to be a float number. That will probably be between 0 and 1. 0 is going to be complete silence, no sound. And 1 is going to be the maximum loudest sound your system can make without distortion. The amplitude is going to be between 0 and 1. But my hue rotation is between 0 and 360. Or, you know, like we can target a different area, like 0 and 100. Right, so I can take this peak amp value, I can use the object, my favorite object, scale, and I can give it its 4 arguments. My input, lowest and highest values, and my output, scaled lowest and highest values. So I will be telling scale, the input is going to be between 0 dot and 1 dot, float 0, float 1. But the output should be between 0 and, I don't know, 125 or 150, right? The input is between 0 and 1. The input of the peak amp becomes the input, which is between 0 and 1, and scale this to a range between 0 and 150. And look, now, as we are about to hear, our visualization is respecting the amplitude. The amplitude is modulating the colors of our visualization, which I find really beautiful. But we can take things to the next level by taking the output of jit.fx hue and plugging it into jit.fx slide, right? So we are creating a visual effects chain. This is really cool. And now if I put the result of jit.fx hue to jit.fx slide, and then the result of that into jit.world, check this out. Beautiful visuals. And finally, we can use one of the latest objects in Max MSP, an object called jit.fx.vhs, and I think it's supposed to just, let me see, the help file says it is a VHS playback simulation effect, which I absolutely love. Right, so I can put the output of jit.fx slide into jit.fx VHS, and then that goes into jit.world. And look at this. This is like a beautiful visualization from like the 80s or something, right? So it just reminds me of like pieces by James Whitney, for example. Simply beautiful. And the final thing we can do would be to take these values, right? These attributes we have changed, like the height and the mode and the BRGB and the FRGB of jit.graph, and kind of bake it into the object so we don't have to do this manually each time. And a cool way of doing this is to unlock our patch, go to this little green triangle here, click on it, go to transform, go to changed attributes to arguments, and see what happens. Boom. Now all these things we have changed are just immediately baked in as attributes for our object. Let's do the same for jit.catch. Right click, not right click, go to the green triangle to the left, transform, change attributes to arguments, and nothing happens. Well, it doesn't matter. We can always hard code it. Frame size 1920. In any case, there you go. We have a cool visualization, and the next steps would be to work with more jit.fx objects, right? Or try to bring in multiple sources of audio, or explore different kinds of audio that are, not audio samples, but maybe a live microphone inputs, or I don't know, some kind of synthesizer that you would play in real time. In any case, I really like this visual. I think you can make very cool audio visual art and visual music with this. And as always, thank you for watching.